Troubleshooting XenMobile from a network perspective. So the motivation to create a little video clip is just to give you some additional options when tracking down XenMobile issues. So before I go and have a quick look to the network setup, obviously the normal way how you're going to troubleshoot XenMobile is a standard approach you know from other products. Like, first of all, collect a couple of log files. And since the introduction of XenMobile version 9, we actually got quite a nice tool included into the app controller, and I want to show you that one before I'm going to look to the network side of troubleshooting. So in version 9 of the XenMobile app controller, we created a page. It's just behind the normal URL. You just add a support slash, and then you can configure your Netscaler gateway. The app controller and the XenMobile device manager provide the credentials, and your app controller will actually collect all the log files from the different sources and give you access to a combined archive, which is very easy to download and dig into that. But again, let me go back and show you a couple of other options. And the reason also why I created this presentation right now is because I'm quite excited that with the latest beta version of Wireshark, we actually get native Mac OS support. So I'm running OS X here on my computer, and really don't like to start the X Quartz, so the X Windows implementation of OS X. So the latest Wireshark Beta version allows you to run that native on your operating system. If you're on Windows, if you're on Linux, you got that for a long time. So it's very convenient. So, but before we do so, let me just make a sidestep and give you a little overview about how the communication flows. And again, typically I would start with looking to the log files, maybe starting on the endpoint. You know that your works home, the central endpoint software, if you wish, can collect logs and send it to you, so you can always see the struggles or the behavior of the endpoint communication. And as I mentioned before, the server side is even more convenient because you get a central location, you get all type of logs together. But there is always a reason that you really want to, you don't see it in the log files, or you really know it's something on your network configuration, or you just want to get evidence or verify your discoveries from the log files. And that goes a little bit into the direction, and I have a background on network troubleshooting in my previous engagements, and so I always keep saying the packets never lie. So I always trust what I can measure on the network compared to what the systems tell me from the top-down view. So, but again, let me go quickly and show you the architecture and just a little bit of layout, how the communication would flow. And here on the left side, you see our endpoints. So in my case, I used an iPad to create those traces. So I'm sitting on an iPad and I'm connecting for the first time, we call that the enrollment process, to our XenMobile Enterprise Fabric, which is in a lab in my home basement. The first thing I would do, I enter my email address or the full qualified domain name of my XenMobile server, which is my XenMobile device manager. So the URL will be entered on this device here. I will travel through the internet, those packets will travel through the internet, hit my firewall, and finally end up in a Netscaler and in many of the configuration, and I will talk about the options a little bit later. In a default configuration, you probably would configure what we call an SSL bridge, because the way we're dealing with the enrollment and getting those certificates out to the endpoint devices needs a direct connection, or at least it's the easiest setup. So I'm basically passing the SSL traffic through the Netscaler gateway to my XenMobile device manager. So once I enroll against the XenMobile device manager, and before I go ahead, you might have seen, I hope this is visible on the video clip as well, we are using two ports, at least for iOS. We use 443 for actually all the SSL traffic for Android and for iOS and the other platforms. So the normal day-to-day traffic is on 443, but we got a second one, the 8443, which is used to enroll iOS devices. So only during the first initial enrollment you will use 8443. You also might have noticed that this is also the case for the Windows Phone 8.1 systems. So they are also using 8443. But normal device traffic is 443. So it hits the device manager in my DM set, in my configuration here on the picture. And during that process, this device manager is connected with what we refer to as an admin link to our app controller, because the device manager together with the app controller makes our XenMobile enterprise fabric. The app controller does the whole application management, so that's what is known as an MAM solution, does sandboxing of our own application and other wrapped applications, provide single sign-on, those type of functionality. The MDM server, the XenMobile Device Manager, takes care of the profile management policy, so make sure that those devices are compliant, not being rooted or jailbroken. But the application part again is on this side here, which also means after we did the initial MDM enrollment with my iPad, there will be a second request here to my Netscaler gateway, which goes to another full qualified domain name, where my Netscaler gateway will then redirect the traffic with secure browse to our app controller. The app controller hosts our enterprise app store. So we got two different connections, if you wish, going on. One for the MDM traffic, the other one for the MAM traffic. So this is the basic thing, and obviously you got all type of server-side components which need to be reachable from the MDM server and the app controller as well, which is obviously like the LDAP. So to do the authentication part, maybe you got SharePoint, you get share file integration, you need an SQL server typically. You might have a CA, an internal CA with a Microsoft Cert server who deals with the certificate-based authentication piece as well. So we are not looking at those ones. We really want to look to the device to the endpoint device traffic against the MDM part and against the app controller part as the primary point for troubleshooting. Now, if we do so, we also need to be aware of how do we deal with those certificates, because all the traffic we're doing, it's basically SSL. It's encrypted. The two servers, so the MDM and the MAM part, those are two different SSL setups we need to support. Now, there is a little difference again, and we'll see that a little bit later. The MDM cert, and if you did install a device manager, you might have seen that that's always tied to the full qualified domain name. By default, you would have a self-signed certificate, same for the app controller. Now, one thing which is a bit of a hurdle for us from the networking troubleshooting side is really that the MDM server uses by default a Diffie-Hellman algorithm, which makes it hard for us to decipher and decode so we can actually see the clear text, because that's what we want. We want to see what type of information is requested from our Works home or from our Works application against our app controller or against our device manager. So on the MDM side, by default, we got a challenge. We'll talk about how we can overcome those challenges. On the MAM side, that is more straightforward. We're using RSA as the primary method, and RSA is supported to be decoded and decrypted by, for instance, the Wireshark protocol analysis device. Now, maybe to get a bit of the understanding on the SSL side, and again, we could talk about SSL for an hour, so I could create a separate module about just talking about what different formats we're using, what is supported on what type of an appliance. So this is just a high-level overview, and I always refer to, if there is always a common denominator in this world, it's called OpenSSL. And I do most of the certificates based on OpenSSL. It's just easy. You always get a command prompt somewhere, so you don't need a GUI, and you see as a really kind of a subset of the commands we're using. Like here on the first line, you see the G in RSA, so which means we are creating an RSA key, which is 2K in length, and that's the name we're using for that key. So if you would create an app controller certificate, we would probably start with those ones, and then we do a certificate signing request. We can do that on the command line too with OpenSSL RIC, a new signing request. I need to specify the key. That's the key we generated before. And then the output file is the my CSR. Now, I typically would stop here and then take that CSR and maybe throw it against my internal search server, which is a Microsoft search server. So I just copy paste the content of the CSR on the web enrollment page of the Microsoft search server, and I will get back typically a DER based certificate, which I then convert to a PEM. We love the PEM format on the app controller, that's fine. So that would be the right way, and then you import it to your app controller. Now, the thing you need to remember, you always need to get access to that little piece here. Let me go back again. That my key, because that's the piece which enables my Wireshark to really decrypt all the traffic between my iPad and my app controller, right? So the remaining part of this slide is really about how you would do a self-signed one just using RSA. Now, one thing which might be interesting also to mention, and everybody has his own tools. I'm personally quite a fan of the XCA tool for OS X. Because that's like a database. I love it. Whenever I create those CSRs, I create the keys. I do sometimes also create the signing requests out of these little applications. The good thing is that I get kind of a tree view about which certificates are signed by which CA. I also see which private keys are being used and expiration information and so on. I even imported my Apple push notification certificate into that. So I get it all sorted in a single location. Whenever I need access to a certificate or to a key, I open the application and I can export all those elements in all formats you can think of. That's the reason why I kind of like this little management tool for store and database of my keys and certificates and CSRs. So, on the end of the day, what you need to remember is really, if you want to capture network trace and be able to decrypt the SSL traffic, you need to get a Wireshark version which supports that. And the best way is really to look to the About box. If you look to Wireshark About, and let me just go back quickly to my real Wireshark, because that's an older version here. That's the version 1.12. And the thing you need to verify is that the build, the binary you're using, is compiled against the GNU TLS library. If this is the case, you likely will be happily decrypt SSL traffic. So I'm going to do the Wireshark a little bit later and show you live what that really needs. But maybe one step back. In order to capture what you want, certain condition needs to be met. I mentioned the version of Wireshark and verify that SSL libraries are compiled against it. That's one of them. Then how do you really capture network traces in your network? One of the challenges is really the switching fabric of our networking, which means if you got any device like a fast Ethernet switch, gigabit switch, whatever you got, chances are really good that it's a switching device, and a switching device is basically a network bridge, which means it only forwards traffic to the destination port where the destination MAC address can be found. Which means if you just attach your Wireshark notebook, if you wish, or the device capturing on a switched port, you only see multicast and broadcast, but you won't see any direct traffic between my iPad, in my example, and my app controller. So what can you do? Use a shared media hub. So if you go, there are a couple of brands still out there which sell hubs, and a hub, it's actually like a multi-port repeater on Ethernet, which means every traffic is actually regenerated on all ports. So, which means it's transparent for you. The other way is that you use a so-called Ethernet tab. Those are little hardware devices on Ethernet which basically forward all the traffic to a distinct capture port, if you wish. Similar technology with the big vendors like Cisco. They got span ports, which allows you to define and span or copy all the traffic from a certain VLAN or from ports to a span port where your sniffer appliance, your Wireshark, is being sitting and capturing all those packets. Wireshark needs to be able to capture in promiscuous mode. That means all the traffic, not only the one which matches your MAC address. That is in some of the platform. It needs to be specified specifically, or the Wireshark software needs to be run in a certain user space. Just verify that you're able to capture in promiscuous mode. And as I mentioned before, the RSA key needs to be accessible. The port protocol and SSL server IP address needs to be configured in the Wireshark. And I'm going to show you that in a minute. Now, where to capture? I mentioned a couple of things already. My preferred one is always, I'm having a little PC sitting on my DM set on the internet side, and I'm capturing all the traffic over here. So if I do that one, I can be quite secure that nothing has been manipulated by my firewall with any type of port translation or my Netscaler gateway. So this is like the raw data which I prefer to capture on whenever possible. Obviously, same thing you can do capture after the firewall, which typically shouldn't make such a big difference, but the addressing typically has changed already because you're using address translations between the external and the internal network. And then there are some other options, right? On the Netscaler gateway, the Netscaler gateway is our appliance we use for remote access in XenMobile and XenDesktop, XenUp. We do server load balancing, so it's really a full-featured controller for providing access to application and protocols and security type of operations. The Netscaler itself can create captures. So that is for sure something. If you have no choice to get physical access to your DM set or external network, then you should be able to capture on the Netscaler appliance itself. I'll show you that also after that slide. And another option, and this is probably one of the only options, valid options for a quick access to network traces for the MDM part. You install Wireshark on the Windows host operating system of the XenMobile Device Manager controller. So it can actually capture the traffic after it has been deciphered. Not always a good solution, as people don't like to install like a packet capture engine on a server side, but for testing purposes it's fair enough, and so that could be one of the considerations. Now on the app controller we got a little bit another challenge, because the app controller is running on a Linux based appliance, and you will not get access to a shell, which means you have no options to install the packet capture engine on Linux, the PCAP engine, which means you cannot capture on those units at all. And this is really the area where I focus the presentation on, because that's when the only choice is really to capture it on this side here. Again, maybe outside, specify what traffic is coming from your iPad or from your mobile device to the app controller, or probably a better way to say against the VIP, the one serving the app controller, so the virtual IP from the Netscaler, and then specify what needs to be decoded. So in order to get app controller traffic being seen, getting a view into the packets, we definitely need to get the capture on outside of the internal network, or we can do it on a Netscaler side, but we also need the required RSA keys to decipher and decrypt the conversations. So this is basically the options you got where to acquire those network captures, those network traces. Another thing, another option for our device manager is really, if you, and you might do that already, one of the things which is getting very popular is using the Netscaler as well to do the SSL offloading piece. SSL offloading is a great thing. It's like it's a reverse proxy technology, and it means while Works Home is talking to our SSL offload vServer, which HTTPS, and during the enrollment 8443 HTTPS, the Netscaler will hold the certificates and the key of the MDM server and say, hey, I'm your MDM server. So the Works Home really does the enrollment physically against the Netscaler clients. And on the backend side, we created a service which uses standard HTTP to talk to the MDM appliance, to the Netscaler device, to the XenMobile device manager, right? So this is a perfect way how you can capture already decrypted HTTPS traffic, because it is already HTTP, because our vServer, our Netscaler appliance, did the job for us already. So I don't want to say that SSL offload is the primary, or the reason for configuring SSL offload is because you want to capture your network traffic. So maybe that's just a nice side effect, because the main reason is really that you can terminate your SSL connection on a Netscaler box in the DM set. And I don't want to go into the discussion where the MDM server has to be installed. In our example, it's in the corporate network. Not always the right decision to do. But SSL offload, again, you terminate the SSL connection in your DM set. That's one of the big advantages. And the second one is really, you take away all the number crunching of the MDM server. Think about, if you get an MDM server here, you get thousands of connections from your mobile devices. All those connections need to be decrypted by the processor of the MDM server in order to get access to the data which is encrypted in the SSL protocol. So if you get a Netscaler box, specifically a hardware base like an MPX or an SDX, we got those SSL chips on those on the hardware boxes, which do all the number crunching anyway. So could be a big advantage for scalability too. Again, in my presentation, I refer to that one as a perfect kind of tab to get your network traces from for the device management traffic. Good. Now let me just stop here and let me go to the product quickly. And before I go to the Wireshark, maybe let me show the example of your Netscaler gateway capture capabilities. So you see, here is my Netscaler, and if I go to my configuration, you see that my Netscaler gateway WIP I'm using, there is one here. That's my Netscaler WIP, where my mobile device talk in order to get access to my app controller and the enterprise store. So that's done with those policies. You might know that already. If not, we got great training modules actually also for configuring Netscaler and setting up XenMobile Enterprise Store as well. So this is really my address in here. If I want to capture, I would go to the system diagnostic screen, and on the diagnostic screen you get start new trace in the technical support tools, and starting new traces will actually be able to create packet captures. The only thing I really need to remind you, if you never did it before, that job applet should just come up typically on the wrong window. Let me see. Oh no, it's here. Okay. No, it's coming from to my other screen as well. So you define the packet size, so we can do packet slicing. You typically are not interested into the payload too much. So if you download like an application, a mobile application, an APK file for an Android or an IPA file or those are actually MDX files in our terms because those are wrapped files. But just a binary native executable, you don't want to capture the payload. If you get like 128 bytes up, you typically get enough information to get all the headers being captured, because that's what we're interested in. We want to see what type of a device, what type of a protocol they're using, what are the protocol headers like in HTTP, do we have things like a user agent, what type of a software is asking for requests to the app controller, because we base also our policies and the profiles on those informations. So packet size, duration of data per file, so how long do you want to capture, the format, that is important. If you look to the format here, always change to TCP dump, because the TCP dump format is the one we import or load into our Wireshark application. NSTrace is not compatible, so you could not decode the protocols with Wireshark. And also an option to create separate trace per NICs, because you might have multiple NICs, multiple VIPs, which you don't want to mix in a single trace. You want to have them separated per NIC, so they have a naming for those files on the very end. And you could basically make some PCAP filter expression, so you just want to get a single IP. You can specify that in here. And on the capturing mode, default is packets buffered for transmission and received packets after the NIC pipelining of the Netscaler appliance. You can actually specify that a little bit different depending on what we're looking for. For my use case, the default here is really good enough. The only thing I typically do, I change to TCP dump in order to be able to decode that in my Wireshark appliance. Now let me close that and let me see where my Wireshark is. So move that over here to full screen, and it looks a little bit different than before. As you remember here, just show about Wireshark. This is a beta version, it's an early version of the 2 code 199. Again, I'm really excited because this version doesn't need my X quartz anymore on OS X. So it looks a little bit more OS X on the top, on the button bars, on the functions. The decode window looks a bit better, but what I verify here again, it's that here GNU TLS, it is compiled with GNU TLS, which means I can decode encrypted SSL traffic. Good. I open a trace which I have actually captured on I'm using in my home lab. I got a cable connection, 150 megabit cable connection here in Switzerland. We're quite comfortable with the bandwidth. So I installed a shared media hub on the external network before my firewall, and I got a network interface of a set box, a little PC, which is running Linux and Wireshark to capture the complete traffic of an iOS enroll. I just wanted to see what is happening if I'm going to enroll an iPad against my XenMobile Enterprise 9 fabric. So I'm going to load that trace here. No, before I load, I need to show you the necessary configuration, because that's the most important part. Let me go to the preferences, and in the preferences you need to check the protocols, and in the protocol section, so those are all the dissectors you get, the protocol decode modules you get to make human readable text out of a stream of bytes on your cable. I'm looking for SSL, RSSS, here it is, SMB, SSL, here it is. And as you see here, there is already a configuration explaining those ones. The important step I need to do, I need to import my RSA key. So I edit here the configuration, and as you see here, As you see, also the port number is needed. So if I would add something here, just an example here, 1.1.1.1, I want to use port, typically this is port 443, and this field here specify what type of a protocol do I want to use for decoding. Now we know this is 443, it's coming as an SSL. We decode the SSL. Inside SSL, we typically got HTTP. And the last thing is really, I need to get access to my RSA key. I just load any key I know which is related to the server. Right, this is my server address here, 1.1.1.1, or better, is probably the one on top here. And the SSL private key of that server needs to be in the configuration of the SSL decrypt setup. Removing that again, I just did actually the MDM controller out of curiosity and to prove that this is not working. I imported both of them. I know that it's not working because by default the XenMobile device manager is using Diffie-Hellman and not the RSA keys, and therefore we cannot do that as easy as with RSA. The decryption process is not that straightforward, so I'm kind of ignoring those ones. I could, however, maybe instead of installing a Wireshark appliance on your MDM controller or doing the SSL offload, the other thing you could do is create a new certificate which is based on RSA. And exchange that certificate, because you typically will do that anyway if you need a full qualified domain name based certificate which is valid on the internet. Would be another option to do. So I'm actually only looking to 443, going to my app controller. This is the external address of my app controller, if you wish, or my VIP of my Netscaler gateway, and then he should decode that traffic as HTTP. This is the trace I took outside of my firewall, so that's a pure internet-facing traffic, if you wish, and should contain all the packets related to an enrollment process from my iPad against the device manager, the XenMobile device manager, and the app controller. So, as expected, a typical communication on the network starts with a three-way handshake on TCP. If it's TCP-based, then HTTP and HTTPS is based on TCP. So you see the three-way handshake in the first three packets. That's a SSL. And the next thing we'll see, and just to make sure it's understood, the 233, so the last octet of that IP address, that's representing my iPad. And you might remember from the setup of when we entered our key and protocol and port number in the SSL configuration 121, that's our MDM controller. So my iPad talks to the MDM controller and introduces what the iPad is capable of in regards to SSL. So that's in the client hello, and you see the cipher suites here. They got 37 of them, so they could negotiate to any of those to set the parameters for the encryption, for the encrypted channel between the iPad and my MDM controller. Now the server will respond with a couple of parameters, and then finally there is a key exchange taking place, and that's what I'm interested in here, to see exactly what they agreed to. And let me see, oh, that's Diffie-Hellman. I knew, and even if I entered the MDM controller IP and actually imported the Diffie-Hellman key, it won't be able to decode that traffic because it's still encrypted. And the way Diffie-Hellman is dealing with the encryption hashes is not that static like with RSA. So for a protocol decoder, it's not just a matter of importing a key in order to decrypt the traffic. So, which means we are pretty much blind. And that's how a device traffic looks like on the internet side. Let me just go, they finished the agreement setting up SSL, and here is our application data, again, between the iPad and the XDM server. So that sounds to me already like they start enrolling the device by whatever messages they exchange, encrypted, because we can't see it. Look to the encrypted application data on the internet. The only thing you see here, it's hex numbers. It's a stream of byte, and we cannot really make any sense out of it. But again, I'm more interested on the app controller side, because the app controller is the piece which is locked down. It's a Unix appliance. We don't get access to a shell the command line, so we cannot install any capture tool like PCAP. I'm really interested to get that traffic being decrypted from packets I have captured on the internet side, or somewhere in between before it's going to the locked box. So I have the data here. What I need to search is actually for the app controller, and the app controller, you might remember, has something with the last octet. It's a 130. But we should see that anyway if I browse down, because different protocols will use different colors here in Wireshark. So if I see a different color here, and HTTP, if it's decoded as HTTP as I did set it up, it should be actually green. That's all encrypted. And if I look to the address 121, that's still the MDM part. That is still not much going on here. That's still the MDM enrollment. Okay, there is some more. 121, still MDM. And then we got the 130, right? Ah, here we are. We got the 130. We see on the 130 maybe some data exchange. Oh, here it is. Remember? Client key exchange, right? Aha. There should be a little bit, where is it? Here, client hello. That's where we started before too, right? Exactly the same. So the client says, hey, dear app controller, you want to talk encryption with me? Those are the different dialects which I support. And then they finally agree to an encryption algorithm. And obviously, and luckily enough, we're finally ending up with an RSA-based technology. So we are able to decode. Okay. Now, the key exchange, that is still encrypted, but let me see. Here is where we really start using our key and decrypt the encrypted traffic. So you see that my iPad is talking to my app controller, TCP. Hypertext will be decoded, and you see here we are asking get HTTP 1.1. It's just the root document on the host access gateway XenCloud. And the next one, we are looking for a frame called for a page called index.h. And let me just see, go back again on the get HTTP. The decode looks a little bit strange. I have that different in some of those. Let's see, here is the get. Here it is. That should be actually decoded in the text field as well. I wasn't really happy about the protocol decode with my OS X version, the Wireshark 1.99, which is not a released version. I found that I had better results in the protocol decode, so I just wanted to verify quickly that our decryption and the decodes are working as expected with the released version. So same setup. I just use now an X11 connection to one of my Linux appliances. You see Wireshark version 1.6.7. That's the one I'm using on Linux. The same trace has been loaded, so that's a PCAP file for my set box. You also might recognize the connection setup. We will have the SSL handshake and so on. I'm not interested in going over the unencrypted, undecrypted traffic anymore from the MDM side, because we know that's not going to work in the current setup. So what I really want to do is a filter between my iPad and the app controller, and hope to get a little bit more visibility into our app controller traffic. So I'm setting up an IPRS filter for the two hosts, and that looks already good from the filter perspective. We got that client hello, remember that, talked about that before, getting all those different cipher options, the server hello, the certificate negotiation, and then we actually get a little bit more on the decipher of the HTTP protocol. So again, this is all HTTPS, it's all SSL, but we decrypt because we provided the key and the IP port number, and then just forced Wireshark to apply the protocol decode of the HTTP protocol. So first thing we see, as before, it's a GET request, and the hypertext protocol looks a little bit, decode looks a little bit better. You remember we didn't have actually user agent in our protocol's detail view. So that's in here now. That looks good. You get a response that the object has been moved, and you're probably going to another one, VPN index. You see that, right? So it points actually to VPN index. It's going to request that page. See if there is anything else we can see. That's okay. And it looks like we need to do authentication first, right? So the iPad needs to authenticate against the app controller, which means it's being terminated on the Netscaler side, and the Netscaler will do the authentication typically through an LDAP interface. Also here, that's a redirect message, and then you see login HTTP 1.1, object moved. Let me go ahead, and then we got a new session set up, and it's trying to set a client for iOS. That's the typical VPN command. If you're trying to do micro VPN, that's typically the first sequence we see. Also here, it's a redirect message coming back, and then we got kind of an access to a services URL. That's okay. Access gateway services, discover. Here is a 200 OK message on HTTP level, and so on. So you see, we're using connectionless VPN to talk to a server called AC2. That's my app controller in my lab. And we're going to look up roaming accounts. We do the authentication, ask for the token. And so that really looks much, much better than before. However, just keep in mind, the decryption part did actually work on the previous example as well. If I look into the hex window, or kind of the really bottom window here, I could see, even if I wouldn't see the clear text here in the summary, in this window it was clear text. So the decipher, the decryption process worked, but it looks like the beta version doesn't properly force the protocol decode I wanted, like the HTTP. So here is the authentication taking place, and you're probably going to see connection to store, right? Going to the store. That's how we talk to the enterprise store, right? With that, we should be able to pinpoint and drill down to the communication problem, if there is any, between your mobile devices and the app controller. Maybe to just conclude what we just did, to acquire encrypted network traffic and decode the traffic and decrypt the SSL data stream, you need Wireshark. Double check that Wireshark is compiled against the GNU TLS library. You need a RSA key, and you need potentially a network tab or a shared media hub, an Ethernet hub, in order to acquire those packets. Alternately, use Netscaler. Netscaler has a capture engine built in, or worst case, install a Wireshark software on the server side.